Welcome. My name is Andy Rivenis, and I'm a product manager for Database in Memory. This video is going to show you a demonstration of the difference in performance between Database in Memory and traditional row-based data. This demonstration was put together by Richard Exley and the Database in Memory team for Oracle Open World 2017. This is Oracle's safe harbor slide, and just says that you shouldn't make any purchasing decisions based on the information provided in this presentation. Database in Memory is fully integrated into Oracle Database and fits into the Oracle architecture as another option to significantly increase the performance of analytical workload. Let's start with a quick review of Database in Memory and why analytic queries run so much faster when the data is populated into the in-memory column store. Oracle Database in Memory is focused on transparently accelerating analytic queries by orders of magnitude, enabling real-time business decisions. Using Database in Memory, businesses can instantaneously run analytics and reports that previously took hours or even days right on the source data. Businesses then benefit from better decisions made in real time, resulting in lower costs, improved productivity, and increased competitiveness. Since Database in Memory does not require or use existing analytic reporting indexes, those can typically be dropped. The resulting workload savings in mixed workload environments, that is, transaction processing and reporting environments, can see a significant reduction in overall workload while gaining significant analytic reporting performance. Embedding the in-memory capabilities into the existing Oracle database software ensures that you get leading-edge in-memory performance without the need to restrict functionality or accept compromises, complexity, and risk. Oracle Database in Memory is fully integrated with the Oracle Database's renowned scale-up, scale-out, storage tiering, availability, and security technologies, making it the most industrial strength offering on the market. Deploying Database in Memory with any existing Oracle Database compatible application is as easy as flipping a switch. No application changes are required. Database in Memory is also cost-effective even for larger databases. It is not mandatory to have all data in memory. Frequently accessed data can be kept in memory, while less active data can be kept on much lower cost flash and disk-based storage. Row format data is optimized for OLTP workloads. OLTP operations tend to access only a few rows, but touch all of the columns. A row format allows quick access to all of the columns in a record, since all of the data for a given record is kept together in memory and on storage. Since all data for a row is kept together, much of the row data will be brought into the CPU with a single memory reference. Row format data is also much more efficient for row updates and inserts. Analytical workloads access few columns but typically scan the entire data set. They also usually require some sort of aggregation. A columnar format allows for much faster data retrieval when only a few columns in a table are selected, because all of the data for a column is kept together in memory and a single memory access will load many column values into the CPU. It also lends itself to faster filtering and aggregation, making it the most optimized format for analytics. Up until now, you have been forced to pick just one format and suffer the trade-off of either suboptimal OLTP or suboptimal analytics. Database in Memory changes that. Database in Memory allows Oracle Database to optimize both analytics and mixed workload OLTP due to our unique dual format architecture. Up until now, databases have forced users to store data in either columnar or row format. Columnar format is highly efficient for analytics, but imposes very large overheads when used in OLTP environments. Similarly, row formats enable extremely fast OLTP, but are less optimized for analytics. The dual format architecture of Database in Memory eliminates this trade-off by representing table data simultaneously in both traditional row format and a new in-memory columnar format. It does this while preserving the Oracle transaction processing model thus allowing both formats to be simultaneously and transactionally consistent. And since no on-disk formats are changed, all existing Oracle database technologies can continue to be used. Oracle Database in Memory transparently accelerates analytic queries by orders of magnitude. But where does that speed up come from? Data populated into memory is stored in a columnar format. A columnar format allows for much faster data retrieval when only a few columns in a table are selected, because all of the data for a column is kept together in memory. An Oracle database only has to access those specific columns, making it much faster than accessing the same data in the row store format. During the population of the column store, the data is compressed. The compression format used in memory is different to those used on disk, which are focused solely on reducing disk space. The compression used in the IM column store is focused on performance and not just saving space. When queries are executed against the in-memory columnar format, the data can be scanned and filtered in its compressed format. The data will only be decompressed when it needs to be returned to the end user. By processing the query on the compressed data, the volume of data that needs to be accessed is greatly reduced. A further reduction in the amount of data accessed is possible due to the use of in-memory storage indexes that are automatically created and maintained on each of the columns in the IM column store. Storage indexes allow data pruning to occur based on the filter predicate supplied in a SQL statement. An in-memory storage index keeps track of minimum and maximum values for each column in an in-memory compression unit, or IMCU. When a query specifies a where clause predicate, the in-memory storage index on the reference column is examined to determine if any entries with the specified column value exist in each IMCU by comparing the specified value or values to the minimum and maximum values maintained in the storage index. If the column value is outside the minimum and maximum range for an IMCU, the scan of that IMCU is avoided. The Oracle in-memory columnar format is designed to enable very fast SIMD vector processing, or single instruction processing multiple data values. You can imagine SIMD as essentially array processing. Let's assume we are looking for the total number of sales we have had in the region of California this year. The sales table is stored in the in-memory column store, so we simply have to scan the state column and count the number of occurrences of the state of California. With SIMD processing, we can check multiple values or entries in the state column in a single CPU cycle. How many cycles or instructions can a CPU do in a second? The technical answer is a lot, enabling us to scan billions of rows per second per CPU core. Along with speeding up all aspects of scan operations, database in memory can also help improve the performance of filter, simple aggregations, joins, and group by aggregations, which are critical parts of most analytic queries. As part of the scan of the columnar data, filter predicates can be applied, and so can simple aggregations like sum and max functions. With database in memory enabled, the join between tables can be converted into a scan and filter operation with the use of hash joins and Bloom filters. Bloom filters are a technology that has been in the Oracle database since 10G. This allows database in memory to take full advantage of what in-memory is best at, fast scanning and filtering of data. With database in memory, the optimizer can also convert group by aggregations to take advantage of a new access path called vector group by. This allows the joins and group by, or aggregation, to occur simultaneously within the scan of the large table, rather than waiting for all of the table scans and join operations to complete before beginning the aggregation. Now that we've reviewed what database in memory is and what it can speed up, let's see it in action. The purpose of this demo is to show that with database in memory, real-time analytics are not only possible, but much faster than data queried in the row store. This eliminates the need for separate analytical systems and can provide customers with information not previously possible to obtain because of the high workload requirements of running analytic reporting directly on their mixed workload systems. No application code changes are required, and all Oracle database features are available. Oracle Database is running with database in memory, and the data being queried is fully populated in the IM column store. The database was run on an Exadata X7-8 system with 384 CPU cores. Transactions query real-world weather system data covering the past 21 years. The application interface allows user selections based on regions or cities and temperature aggregations like average temperature or number of days where temperature was greater than some value. This could be on an annual, seasonal, or monthly basis. After the user chooses the query to run, the application runs both a row-based and a columnar-based query at the same time. The demonstration is completely user-driven with both time and location choices, and the query aggregated over the 21 years of temperature data. You can see that we have a map of Europe with cities marked and then a time frame choice at the top. We then show the performance to the right of the screen with columnar on top and row on bottom. Let's take a look at some queries. The first query shows the average temperature in Paris during June by year for the past 21 years. Note that we have picked both the time frame and then Paris on the map, and note the top query, which is the columnar formatted query, runs significantly faster than the bottom query or the row-based query. Now this second query will show the average temperature in Berlin during the fall for the past 21 years. Note that the top query, the columnar formatted query, is already completed. And we're going to let this run a little while longer. But notice that now the bottom query, the one querying the row store, has just kind of gotten started, and it will now run for quite a bit of time. We won't look at the whole run, but if you notice, it's going to take much, much longer to run than the columnar-based query we ran on top. The third query will show the average temperature in Vienna annually for the past 21 years. So we'll pick both the Vienna for the city, and then we choose the annual bar at the top. And notice that the in-memory query is already complete. And now the row-based query is running, but it's going to again take much longer than we're going to be able to watch. Notice that the first bar has displayed, but this is just going to take much too long for us to watch the entire run. Next, we're going to look at the average temperature in the south of France during May for the past 21 years. Notice that we're going to choose a region this time rather than a city, and then we'll pick the month of May, and the query will take off, and the in-memory query will finish blazingly fast, and actually the row store query at this point will also run fairly quickly. For the fifth query, we're going to show the number of days over 80 degrees in Paris during August. Notice that we're going to go down to the bottom temperature slider and slide the temperature to 80, pick Paris, and then we'll choose the month of August, and our query will start. Notice the in-memory query finishes very, very fast, and the row store query is much slower, which is what we would expect from the difference between the column store and the row store. The sixth query will show the number of days over 74 degrees in London during the fall. So we'll choose the fall season, and we'll take our temperature slider and move it over to 74 degrees, choose London. Our in-memory query starts and finishes, and then we can watch the row query, which is going to take quite a bit longer. The seventh query will show the number of days over 74 degrees in Rome annually. We'll pick by choosing Rome, and then we'll go up and pick our annual bar. We've already got the temperature set. Notice the in-memory query is already complete, and we won't even get past the first. We'll get the first year completed before we give up, but the row-based query is just going to take too long. The eighth query will show the number of days over 74 degrees in the south of France during April. So up above, we'll pick April for our time frame. We'll choose in a smaller area in the south of France. Immediately, the in-memory query finishes, and then we'll see the row store-based query run faster than some of the other queries, but still take a very long time. In the ninth query, we'll show the number of days over 74 degrees in northern Spain during the summer. So we'll choose summer in the time frame. We'll take a region in northern Spain. As soon as we've chosen that, we see the in-memory query is already done, and then the row store query will continue to run by year, and again will take much longer than the in-memory query. In our 10th and final query, we'll look at the number of days over 74 degrees in northern Italy annually. So we'll choose annual in our time frame. We'll pick a region in northern Italy. The in-memory query will run very fast. And then, of course, the row store query will take much longer to run as it goes through much more data over the 21 years. So to conclude, this demonstration shows that the in-memory column store is orders of magnitude faster than the row store. To run the demo, no application code changes were required to run in the row store or the column store. Database in-memory takes advantage of all Oracle database features, including partitioning, parallel query, and in-memory dynamic scans. Database in-memory enables true real-time analytics. And here is some additional information about database in-memory. I would strongly recommend checking out the in-memory blog. If you have any questions, feel free to contact me. And hopefully this gives you a feel for how powerful database in-memory is. Thank you for joining us.